welcome to our class, College Calculus. My name is Profe Julian Macias. Today I will teach you integrals. Integral is our class for today. Here we have this concept about what I mean integrals, or what is the main concept about our class today. So the definition of integral, if, for instance, if f is a function defined for a less or equals than x, or less or equals than b, we divide the interval between a and b, so into n subintervals of equal with increase x of b minus a divided by n. The definition integral of f from a to b, we have here the formula, all right? So the integral, so we have a to b, here f of x, differential of x equals limit when a limit approach to infinity of sigma n when I is equals 1. F of this is a little star here when x, we have I here, so when increase x, all right? This is the main formula about integral. So let me show you more. This is the main idea of our class. This is the main concept, all right? So let's erase here the definition about integral, and then let me write another key. Another key that we have it is when we talk, we have to know about the theorem. What I mean the theorem, if f is integral, if f is integrable, so remember on a b here, then this is a theorem. All right, this is very important. We have integral here b, so a to b of f of x, differential x equals limit of sigma, and we have I equals 1 when here as n approach to infinity. We have f of x, the increase x, all right? When this is actually the formula, right? We have b minus a here, n divided by n, and xi equals a plus we have here increase of x, all right? So this is the theorem that we have to know before to start. I will to solve a couple of problems, all right? This is a theory concept. Let's go, and then let me write one problem. Example 1. So in this problem we have to express this problem. Let's write limit of sigma n when I is equals 1 when n approach to infinity. All right, we have our problem here. Let's write x to the third power. I write here plus x I sine x I plus increase x. All right. We have to express this integral. How express? So as an integral on the interval. Let's write a 0 here. 0 pi. Okay. This is our problem. Okay. The solution. What is the solution? Our problem here. Let's write. Let's write some step. So here we are given that we have A is equal 0, right? And B is equals pi, right? See, 0 and pi, right? We have that data there. So then substitute in the formula here. Let me write a limit here. Limit n approach to infinity here. Let's write sigma I equals 1. This is a formula, right? X to the second power, right? Plus x here plus sine x times increase x. See, so this will be equals. So now write the sign or integral sign. Integral equals integral. Let's write here a 0 and then here pi. See, and then open parentheses. We have to write and now here x to the third power, right? And then 1 right here, x, plus sign here, plus sine x, okay? X without this, so now close differential x. That's right there. So in general, when we write it, this, we have to write a limit here. So let me write an n. So here is infinity, sigma, in here, I equals 1 right here. So f x, remember this star, I give it to you this concept, increase x. So this is in general. So this is about the formula. Here we have to write b and a here, or ab, baby, f or x, the differential x. All right. See. So then just we continue. Let me I will erase here. I don't want to erase the whole problem. Just write it. Let me write right here. I will erase this part of the problem to continue here, right here. So we replace here limit. Remember the problem? Limit less sigma by integral, the sign integral here. By x and increase of x by dx. Yeah, we replace those. Okay. So some because here is only we have to express a problem with no big deal. So I am trying to use the variables and the letters in the right way. Okay, integrals. So let me erase it, and then now let me write some formulas that we use with integrals. Very important formulas. So we have to know some formulas. When you work in integrals, we have to know some formulas. We have a lot of formulas. I'm gonna write the most important here. So how evaluating integrals? This is very important formulas. Just I will write some number here. I don't want to write everything. So the first, the number 5, let's write sigma here. N I equals 1. Okay, this formula is I is equals here. When you have n, we have n plus 1, right? Divided by 2, right? The next one, number 6, let's write sigma n I equals 1 is here. This one is a square, I square equals, when you have like this problems, we have to use apply these formulas. N plus 1. I'm gonna show you some problem. 2n plus 1. I will to write solve one problem using one of these formulas. Okay. So let's write 7 and I equals 1. So here is I. The third power, first power, second power, third power. This is a number 7. Let's write open like this. And number 7, when you have m times m plus 1 to the second power divided by 2. I mean, let's write like this. Okay, to the second power. That's a number 7. All right. Let me. I will erase this to continue with most of these formulas. We need to memorize when you have some problems to use it to solve our problem in integrals. We have to use when we have problems in integrals. This is how evaluating integrals. So number 8 now. Just I want to write some, not everything. So number 8 is we have n I equals 1. So the number 8 is in this way. It's a little different. It's constant. Right here is NC. Number 9. Number 9 is number 8. Number 9. We will have a sigma again. Sigma n I equals 1. And number 9. Now we have A like this. I mean, like this. Equals C. This is constant, okay? Constant. A8, right? A8. Number 10. Let's write the number 10. number 10 is like this, and I equals 1. Let's write AI plus BI close equals and sigma AI plus again another sigma here, so n equals 1. All right, plus BI. It's a number 10. Number 11, let's write the number 11 sigma again, and I equals 1. I plus BI equals, and I equals 1 right here. AI sigma is equals sigma, and I equals 1 BI. All right. See, I think this is the most important formulas, and then with these formulas we are able to solve the next problem. So let's see example number 2. The first one only, the first example was only for express the variables. Now we are going to use some of these formulas to solve example number 2. Example 2. Let me write the problem. Evaluated in the Riemann sum for f of x equals x to the third power minus bx. All right. So taking the example, the example, let's point the points to be right M point and A equals 0, B equals 3, and N equals 6. Remember these formulas? So this is one thing. Number 2b, we have to evaluate to a couple problems. 3, let's write by 0, x 3 dx. So the solution. All right, let's see the solution. And number 1, we have to I don't have enough space, but let me write the solution right here. And number 1, I mean the A1, the solution. Let's write the variables, and this is n equals 6. The interval with it's a width. Interval width. So let's write right here increase x, right, equals b minus 8 divided by n. So equals 3 minus 0, right? Divided by 6 equals, we have 1/2 the answer right there. And the solution is not yet. And the right endpoints are, let's, and the right, endpoints, the right endpoints are, let's write the points. I will to write the points, okay? I will erase the problem. So I don't have enough space here. So let's write x. We have the x here, 1 equals 0 plus 5, right? Oh, no, 0.5. Endpoint 0.5. x1, right? And then x2 will be equals 1.0. x3 equals 1.5. And then x4 equals 2, right? 2.0, right? 2.0. And x5 equals 2.5, right? And x6 equals 3.5 equals 3.5, right? 3.5. So then I will erase the problem. So you wanna see, just let's write this. We are here, so we continue here. So the Riemann, so the Riemann is, let's see, will be R6 right here. R6 equals sigma, just write number 6 right here. I equals 1, right? F x I x increase of x, right? So this is equals, I will erase everything. Why? We are there. So we are there. Remember these numbers. So now simplify. Now we have to simplify all the information here. We will have f of 0.5, right? Increase x plus f everything 1.0, right? Increase x plus what else? F 1.5. Remember what is the next one? Increase x plus, let's continue, f 2.0, increase x plus f of 2.5, increase x plus f 2.5, 3.0, right? This x, all right? So now equals here, simplify. We have to simplify here. We will have 1/2, remember, 1/2 times, let's write here a -2, let's write all numbers there. negative 2.875, all right, minus 5, minus 5.625, minus 4, plus 0.625, plus is 9 right here, 9. So you simplify everything. So the answer will be negative 3, negative 3.9375. So that's the answer for the first part of our problem. Remember part A. So now let's go part B, the last part of the solution of our problem. And we are talking about example 2. So on the last part we have B. Here, remember B? Let me write. So with n, we have with n subinterval, we have, so we have increase x equals b minus a divided by n equals 3 divided by n. All right. So then we have x here, x 0 is equals 0, comma x1 is equals 3 divided by n, and then x2 equals 6 divided by n, right? x3 is equals 9 divided by n, right? And in general, xi is equals 3i divided by n. Yeah, it's in general. So here, since we are using endpoints, we can use the theorem Theorem 4. Remember the theorem that I wrote for you before? I explained it at the beginning, the concept about integrals and then one theorem. So we are able to use this or that theorem. Okay. Look at this, and then let me write, because it's it's big process here. So I will erase this to start it in the solution of our problem. Okay, let's see. Let's write integral here. We have 3 and then 0 right here times x to the third power minus bx, right? dx equals limit when here, and remember, n approach to infinity. When n approach to infinity, we have sigma here in I equals 1. So f of xi is increase x. equals maybe we don't have enough space right here. Let me write limit here and approach to infinity there, and again a sigma and I equals 1 plus. Now look, this is very important. We have to write 3i, remember, divided by n. 3i divided by n times 3n. Okay, times 3n. So now it's we have to write this question, right? Okay. Let me explain here. When we have this equation, I mean a with let's say here with c equals 3n. All right. So here is equals right there. We continue right here. We will have limit when n approach to infinity. We will have 3n. I mean 3 divided by n sigma n I equals 1. Open a crochet like this. Write 3i divided by n here to the third power. All right, minus 6 3i divided by n. Okay, and then a close crochet. All right, let's see that step. There's a lot of steps. So simplify here. Here we will have limit n approach to infinity. We have to write 3n sigma n I equals 1. Same information. Now here simplify. So here we will have 27 now divided by n to the third power I to the third power. Okay, minus 18 divided by n. Right? We are there. Here is I, also I, both I, right there. So here so remember the equation that I give it to you here is very important. We apply the equation number 9. Here we have to apply the equation for evaluating. Now equation 9, question 9, also equation 9, also equation 9 right here too. So in this step, so we will have here and then limit when n approach to infinity. Let's now it's we will have 81 right here. Be careful, right? N to the 4th power, and then write sigma n I equals 1. See, I to the 3rd power minus 54. Look at this, 54 divided by n to the 2nd power, right? n to the second power times sigma n I equals 1. Right there? So we are here in this kind of the rule. So it's not finished yet. I will erase this, and then now I will erase everything here. So we continue. Let's continue in equation. I'll apply the equation. Question here 7 and 5. The equation that I give it to you. So take a look at question 7 and 5. So right here, limit, this is equals. Simplifying. We are simplifying the process, okay? And approach to infinity. But here, we have to write 81 divided by here n to the 4. And by the quotient right here, let's write n times n plus 1 here divided by 2 to the second power. Okay, so equals 54 here, 54 divided by n to the second power, and then we have here n plus 1 divided by 2. So here close everything. So in this step, now we have to simplify all data there. Then we will have here limit and then approach to n. Here we have to write, open here, 81 divided by 4 times 1 plus 1 divided by n. Here close to the second power plus 27. Plus 27 times 1 plus 1 divided by n. Close here. Then next step. Almost done. 2 more steps. Limit here when n approach to infinity. But now here we have to write 81 divided by 4 times let's see, it's without crochet. Let's see how we have 81 right here. No limit. It's a conclusion. We don't have to write the limit here. So let's write equals 81 divided by 4 minus 27. Yeah, it's a conclusion equals here is going to be negative 27 divided by 4. And then we subtract here. So use the calculator. We will have this is gonna be the negative 6 point. The answer 6.75. Yeah, this is that was the solution. Remember the question and the problem. Problem number when this the same problem. Pues example number 2. But we have two problems in this problem. Question A and question B. And this is the solution for the B. All right. So that's it for today. So thank you so much to be in college calculus. I am here Monday and Thursday at 3 p.m. Mondays and Tuesdays 3 p.m. So thank you. Waiting for you. Thank you so much.